If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in intermediate level where you are solving previous year JEE Main questions on differentiability. So in this lecture we will be solving 3 questions, question number 1, 2 and 3. Okay, then let's see these questions. See question number 1. If fx equal to this, whether it is not equal to 0 it is given, equal to 0 it is given. You have to see whether it is continuous or differentiable at x equal to 0. So for that you start with continuity. Even they ask you differentiability also, we always start with continuity, because if it is not continuous then there is no need to going for differentiable. So first you check continuity. So for continuity you will do left hand limit and right hand limit. So left hand limit means you can think it, or by not doing also, by putting these values also, it will be 0 plus and 0 minus. So something 0 plus if you do, then what it will happen, 0 plus something, that means it will be very close to 0. This will be also very close to 0. 1 by 0 is infinity. So e to the power minus infinity means 1 by e to the power infinity means 1 by infinity means 0. 0 into 0 will be 0. So if you got it, then I think that's the, you can see that it is left hand limit is 0. Similarly if you do right hand limit also, that will also come to 0. So it is continuous. If you are not getting it, then just go by it. Limit h tends to 0, what we do, f left hand limit, it is 0 minus h. So which one we will put, limit h tends to 0. If it is not equal to 0, we will be using the first one. Instead of x we are putting minus h. So you can see left hand limit is 0. If you put it is 0 minus h, instead of x I am putting minus h, it is cancelling out, so e to the power 0 is 1. So finally if you put h equal to 0, it will get this. Similarly here also if you go by this way, it will be plus h e to the power 1 by mod h minus plus 1 by h. So if you now put h equal to 0, it will be e to the power minus 2 by 0 is infinity, 1 into 1 by e to the power infinity, 1 by e to the power infinity is 1 by infinity, and it is, you can keep it 0 h still, because otherwise you can think it is 0 by infinity, limit h tends to 0 and it is h. So 1 by infinity it is 0, so limit h tends to 0, h into 0, so limit h tends to 0, 0, so it is 0. So you can see your LHL and RHL both are equal, and that is also equal f0, because f0 is also 0. So therefore it is continuous. So option C is not the answer. Obviously you can now get it. It is saying that neither differentiable nor continuous. We have seen it is continuous. Now for derivative you can again do left hand derivative, right hand derivative. For that you can apply that again limit formula, but I am again doing some shortcut for you, because in JEE it is not required. You can express this function as a, you try to express for less than 0 1 function, greater than 0 1 function, then you can, if you cannot express two separate functions, if you are dealing with one function, then you have to go by normal conventional formula, that is original definition of left LHD, limit h tends to 0 f of a plus h minus, original definition of differentiation. But here it is possible because it is mod. So if your x is greater than 0, then there is no need of mod. This is for x greater than 0, and for x less than 0, if you are removing mod, then you have to put minus 1, that is minus x. You know from this function chapter, and at equal to 0 they have already given 0. So your function is looking like x into e to the power minus 2 by x if x is greater than 0, and x into, you can see it is 0, e to the power 0 is 1, so it is simply x for x less than 0, and 0 for x is greater than 0. For so left hand derivative, what you will do, you will do for 0 minus, f dash 0 minus. So what you will do for 0 minus, which function you are taking this function. You would simply take differentiation of this one, that is d dx of x, which is 1. Now you put x equal to 0 minus, there is nothing to put, that means your answer is 1, LHD. Similarly you do for RHD. RHD is f dash 0 plus. So for 0 plus you just differentiate it, and then you put x equal to 0 at the end. Differentiate of what function? Obviously 0 plus means this function. So if you do differentiation of x e to the power, those who know differentiation they can easily do it. So if you take this one constant, then x differentiation is 1. If you take x constant, then e to the power minus 2x is minus e to the power x, and for that minus 2 it will be minus 2 by 1 by x is minus 1 by x square. Those who don't know differentiation, wait for some time. So now if you put 0, e to the power minus infinity is 0, this is 0 into 0 into, and now it is something divided by, so 0 by 0 it is undefined, that means it is going towards infinity, or you don't know what is the answer. Okay, so obviously you can say your left hand and right hand, they are not matching with each other, so it is LSD is not equal to RSD, because your RSD is tending to infinity. If you put 0 here, this x and this x actually get cancelled, so you take 1 by, this is 0 to the power infinity, but it is going towards infinity, so your output is going towards infinity, so that's why LSD and RSD not equal, so they are not differentiable. That means your option B. It is continuous for Lx but not differentiable. Now if you come to question number 2, the set of point where this is differentiable. Again for that you can, there are breakpoints, some -1, 0, and it is saying no breakpoint, everywhere it is differentiable. So I am not checking continuity because obviously it is continuous, that's why they are saying given some range in which it is differentiable. We just check those points 0, -1, whether these problem points having any problem or not the entire function we will think of. So it is x plus 1 by x if x is greater than 0, and x minus 1 minus x if x is less than 0. Anywhere you can put equal to. I am removing that mod function. Okay, now you can check at 0, you check, because other than 0 it is always a poly by poly, that is rational, so it will be obviously continuous. You can see at x equal, you can think of this is at x equal to 1, this will be infinite, but it is not x equal to 1, this is for less than 0, so this will never be 1 by, this denominator will never be 0, and this also will never be 0, so there is no problem at 1. So you can check continuity at 0. So LHL if you do, so f0 minus, so 0 minus means for less than 0 you will take this one, that means x minus 1 by x. So if you put a very small value like 0, so your answer is 0. If you do RHL f0 plus, which function you will bring? You will bring this function. Again you are putting a number which is very close to 0, so you can put it as 0, so is 0. LHL RHL both are equal, and f0 is also 0, because f0 you take this one or this one, whatever, so this is also 0, so it obviously continuous, so no need to. Now we have to go check for differentiability at 0. So for differentiability LHD, that is f dash 0 minus, so you will do differentiation of function which is less than 0, then it is this one, and after differentiation we will put x equal to 0. That is the idea of this meaning. So if you do differentiation, those who know differentiation, it is u by v, v constant differentiation of u. Those who don't know, just do it. We will do it differentiation just after this article. So minus x plus x will be cancelled, it is 1 by 1 minus x whole square. If you put x equal to 0, it is 1. Similarly, if you do RSD, f dash 0 plus ddx of, for 0 plus you will take x plus 1 plus x, at the end you will put x equal to 0. So again if you put x equal to 0, again it is 1, so LSD equal to RSD, so therefore it is continuous at 1 also, sorry at 0 also. Earlier it was differentiable at everywhere, because it is some normal algebraic always differentiable, so that is also differentiable at 0. So obviously 0, you can see 0 is not here, 0 is not here, 0 is not here, because it is differentiable at 0, so 0 should be there, that is your option B. Now if you come to question number 3, if f from R to R is a function defined by this one, fx is minimum of these two functions. Mean means you draw both these functions and the minimum will be the answer, that will be the value of the output. Then which of the following is true? So you have to draw two functions are there, one is x plus 1, one is mod x plus 1. So if I draw this one, what is mod x? Mod x is this one. So what is mod x plus 1? I think we have discussed in function. We will see whether if you have not discussed it, we will discuss one topic you will see in the function, how to shift the function. It is the value, it is for x equal to mod x. Now if it is a plus 1, then it will move up, because everything will start from, if x equal to 0, the output is 1 now. So this is the graph for mod x plus 1, that is a mod x plus 1. And one more graph they are asking, that is y equal to x plus 1. Another one is y equal to x plus 1, one is y is equal to mod x plus 1. So we have drawn this one, mod x plus 1. Now x plus 1, x plus 1 equal to y equal to mx plus 1, m is 1, so this point is already 1 0. So this is the same graph, this one, because if x is, so this entire line is for y equal to x plus 1. Now you have to move from x to y, you have to see the minimum value. Now if I go this side, if I am moving from this side, then out of these two curves, which one is minimum? Obviously this one is minimum, because your function is the minimum of these two. So this one will curve, this one will come until this position, and if it reaches here, both are equal. So if both are equal, then minimum means you can take either one. So that means this line. So your fx is meaning this line. So what is your fx? This line is nothing but it is x plus 1. So if we take minimum of these two, every time x plus 1 will come. So there is no need of giving this one. This is just to confuse you. So you draw both this curve. This is the way to draw mean and max function. And out of these two, the minimum one you shade it. So out of these two, minimum is this, and this side both are equal. So it is the same line, that is you are getting an output. So because if it is this one, so it is fx. They are saying fx is always greater than 1. No, the output is somewhere I have seen the output is less than 1 also. Fx is not differentiable. No, it is differentiable at x equal to 1 because it is polynomial function. Fx is differentiable everywhere. That is option C. If you like the video, then press the like button and please give your valuable comments in the comment section.